Welcome to myiacademy.com. I'm Professor Mahfouz Hussain from Pakistan. In this lecture, we'll talk about the maps and their importance in topography. Do subscribe to the channel to keep seeing the videos. Basically what we'll do, we'll look at the 4 maps in the topography printout and see which maps are more important and which maps are less important. Look at this one. It's a Galilee map and the 4 maps are on the left hand side and the parameters are on the right hand side. Look at the ORB scan. The 2 maps are on one side, 2 maps on the other side, and the parameters are right in the middle. Cirrus CSO. The 4 maps are at the top and the parameters are in the bottom. Now the Pentacam. The 4 maps are on the right hand side and the parameters are on the left hand side. Here we have got all the 4 maps in one slide. Because the maps were developed by different companies, so their arrangement is different, but the information they have got is the same in everyone. So let's see what information they have. All the maps have got a pachymetry map. It is in the right upper corner, bottom right corner, left bottom corner, and left upper corner. So all of them, they've got the pachymetry maps. Then all of them have got the elevation maps. You can learn about the elevation anterior and posterior in the video VPL 1.1, but all of them have got the elevation maps. 2 elevation maps, 2 elevation maps, 1 elevation map, and 2 elevation map, which is anterior and posterior. So all the 4 companies or all the 4 machines we have got in practice or in use have got the pachy map and elevation map. Now what is the rest of the maps? Now look at that. All of them have got a third map which is slightly different. What is the difference? Look, here we have got an axial map. Here we have got a tangential map. In the Pentacam we have got the sagittal map, and in the Cirrus we have got a tangential map. So this third map is almost different in all the 4 of them. Why it is different? So we are going to find that out. So the curvature maps are different in all the 4 machines, while the elevation and pachy maps are almost the same. So let's talk about the curvature maps. There are 2 types of curvature maps. One is called sagittal, axial, or power. They are all the same, just a different terminology, and I've devised a mnemonic called SAP or SAP, which means sagittal, axial, and power map are the same thing. So if you remember the SAP, you're going to need it throughout the course. So the SAP maps are sagittal or axial or power, and it is the same thing. The second thing is tangential, instantaneous, or meridional maps, and have made a mnemonic TIM. Very few companies use the tangential or meridional map, so it's perhaps not as important as the SAP maps. So remember SAP, sagittal, axial, and power map, and we are going to need this mnemonic time to time. Now, what's the difference between the SAP map and the TIM maps? SAP map or sagittal or axial map, it measures the curvature at certain point of the corneal surface. It is most commonly used map. It is helpful in evaluating the overall shape of the cornea, and the biggest advantage is the pattern diagnosis, which we discuss in lecture 1.5. On the other hand, tangential map is for the measure of the curvature at certain point of the corneal surface, but because this work has been taken over by the pachymetry maps and the elevation maps, so nowadays most of the machines, they have got a sagittal or axial map incorporated into the printout. So I repeat, SAP map, which is sagittal, axial, or power map, gives you a general shape, of the cornea, and does it measure the minute details which are actually measured by the pachy map and the elevation maps. We are back to the four maps, and I just revise that the Galilei has got the axial map, Opscan has got the tangential map, Pentacam has got the sagittal map, and Cirrus has got tangential map. Remember, these maps are most fascinating. You can spend hours and hours and days to study them, and the result will be nil. They are most confusing. They don't give you the final diagnosis, and then the final diagnosis will have to be confirmed by the pachy or elevation map, so they confuse you. They are least informative. When I say least informative, that means as compared to pachy maps and as compared to elevation maps, they are least informative. And above all, they are only topography map, means they are not based on the tomography. They are usually based on the topography. So these are most fascinating, most confusing, least informative, and only topography map. And what information they give you is the advantage is they are easy and quick. You can recognize the shape pattern which we discuss in VPL 1.5, and they are good for the pattern recognition and just gives you a clue what you're going to look for. The disadvantage is they are severely affected by the scale and they are subjective, so they don't help you in the final conclusion, but they're good to start interpreting topography. So the take-home message is that the curvature maps are most fascinating, most confusing, and least informative, so we will not be dependent on them for interpretation of the topography. So for the interpretation of the topography in section VPL 1.6 and 1.9, we will not depend on the curvature maps, but we will depend on the elevation and pachy maps. So that is the take-home message, that we will depend and we will start interpretation of the topography from pachy and elevation maps. So let's go to the section VPL, which is a 7-step detailed interpretation guide, and VPL 1.9, which is a quick 15-point guide. Thank you very much for being with me, and do subscribe the channel to keep seeing the oncoming videos. Thank you.